Lesson 59, Fractional Exponents. For m and n integers, so using m and n as integers and n does not equal 0, then a to the 1 over n equals the nth root of a. And n is called the index. That's the little number that goes up in with the root symbol. If there's no number there, no index, it just means 2. Like the square root. So a to the m over n means the nth root of a to the mth power. So whatever the denominator is, that's your index. What the numerator is, that is your exponent on the radicand. So here's an example. If I have 2 to the 3 halves, the denominator, which is 2, means the index is 2. So it's just the square root of 2 cubed. And you can reduce that to 2 square root of 2. Or not reduce, but simplify. Some of the properties of roots, if you have the nth root of a times b, and you guys already know this, I think, that just equals the nth root of a times the nth root of b. If you have the nth root of a fraction, it's just the nth root of the numerator divided by the nth root of the denominator. When n is odd, you can take the nth root of a negative number. That's only if n is odd. Actually, the nth root of that negative number will be a negative number. So the cubed root of negative 8. Because the index is 3, then the answer will be a negative cubed root of 8, or negative 2. When you take the an even index greater than 2, so 4, 6, 8, etc. Here's an example. The 4 through to 16, you're going to have 2 roots, so plus n minus 2. So you will always have two roots only for n greater than 2 and even. So n has to be even and greater than 2. Also, the radicand must be positive. So if the radicand is negative, you cannot take an even indexed root. So for rational exponents, a to the negative n equals 1 over a to the n. A to the 0 always equals 1 no matter what a is. If you multiply two numbers with the same base, different exponents, you can add the exponents. When you divide, you can subtract exponents and leave it in the numerator, or you can subtract and leave it in the denominator. So you would have the denominator's exponent minus the numerator's exponent, and then you leave it in the denominator. When you raise a power to a power, so a to the m to the nth power, you multiply m times n. If you have a product raised to the power, each factor within that product must be raised to the power. And same with division. So each part of the division fraction needs to be raised. Whoops, that's to the mth power. Must be raised to the mth power. Also, we must rationalize denominators if they are irrational. So here's an example, 3 over the cubed root of 5. Because it's a cubed root, we need to multiply by the cubed root over 5 times the cubed root over 5 2 times. That way we have 3 of them, and the denominator will just be 5, and the numerator would be 3 cubed root of 5. 5 squared, or 25. So here's another example. If you had 3 over the 4th root of 5, you need to do the 4th root of 5 3 more times, so I just do cubed that way. So we know the denominator then will be 5, and we have 3 times the 4th root of 5 cubed, which is 125. When you have a fraction for an exponent and then raised to a power, you can use the power rule and just multiply those two exponents. So this is just x to the first power. So here's an example where we might want to use that. X to the 1/3 equals 5. So if we can raise each side to the 3rd power, then we can say x to the first, or just x, equals 125. And another example where we would use that, if we had x to the 4/3 equals 81, then we can raise it to the power that's a reciprocal of this exponent. So we would raise both sides to the 3/4, and we would have x equals the 4th root of 81 cubed. Now the 4th, 81, I guess, is just 3 to the 4th power. So we're taking 3 to the 4th power and cubing it. And that means we have groups of 4 here. So it's just equal to 3 times 3 times 3, or in this case, 27. And that's the end of the lesson.